Welcome, space enthusiasts, to our enlightening journey through the revolutionary breakthroughs in space medicine. Strap in as we traverse the cosmos, unraveling the mysteries of human biology in the vast expanse of the universe. We'll be delving into the intriguing world of space medicine, where the survival and well-being of astronauts in the harsh environment of outer space have led to astonishing advancements. These breakthroughs aren't just benefiting our brave explorers in space, but are also making a significant impact in improving life here on Earth. So stay tuned, our journey is about to begin. Have you ever wondered how the human body adapts to the challenging conditions of outer space? A fascinating field, space medicine, delves into this very question. It's a realm where human biology and the cosmos intertwine, exploring how our bodies respond, adjust, and thrive amid the harsh realities of space. The mysteries of the universe have spurred advancements in medical science, leading to revelations that were once beyond our grasp. Our journey through the past century will reveal the astonishing breakthroughs in space medicine. Our story begins in the 1960s with the birth of space medicine. During the heat of the space race, the medical community found itself facing a new frontier. As astronauts ventured into the unknown, they encountered challenges that were alien to medicine on Earth. One of the most prevalent issues was space motion sickness. Imagine stepping off a dizzying roller coaster and then trying to perform highly precise tasks. That was the reality for these early space travelers. The unfamiliar sensation of weightlessness was disorienting and often led to nausea, a far from ideal condition when you're hurtling through the cosmos. Another hurdle was the disorientation experienced by astronauts. Without a clear up or down, the brain struggled to make sense of its surroundings, leading to confusion and impaired function. These initial challenges were daunting, but they ignited a spark in the medical world. They were the catalysts for a new era of medical research and development. These initial challenges paved the way for the first major breakthrough in space medicine. By the late 1960s, scientists had developed the first motion sickness medication for astronauts. This was a major step forward in the field of space medicine, addressing one of the most common and disruptive ailments experienced by astronauts: space motion sickness. The development of this medication was a byproduct of intensive research into the effects of zero gravity on the human body. Think about it. Without the constant pull of Earth's gravity, our inner ear, which helps us balance and orient ourselves, gets thrown off. This can lead to a sense of disorientation and nausea, commonly known as motion sickness. The medication developed was not just a remedy for an uncomfortable ride, but a crucial element in ensuring the health and productivity of astronauts on their missions. Indeed, the significance of this breakthrough extends beyond space travel. It has also contributed to advancements in treating motion sickness here on Earth, benefiting millions of people worldwide. This breakthrough was just the beginning of a series of advancements in space medicine. The 1970s brought us deeper into the mysteries of the human body in space. As we ventured further from our home planet, we began to notice something intriguing, yet concerning. Astronauts returning from space were weaker, their muscles had atrophied. This wasn't just a minor inconvenience, it was a major hurdle for long-duration space travel. Muscle atrophy is the wasting away of muscle tissue. In the microgravity environment of space, without the regular resistance of Earth's gravity, muscles don't have to work as hard. The result? They weaken and shrink, a process that can start as quickly as 72 hours after leaving Earth's gravitational pull. This discovery led to a surge of research in the field. Scientists sought to understand the mechanisms behind this phenomenon and, more importantly, find ways to counteract it. This research wasn't just beneficial for astronauts, it also had implications for people on Earth. After all, muscle atrophy is a problem not exclusive to space travelers. It affects the elderly, the bedridden, and those with certain diseases. The solutions developed range from innovative exercise regimens to nutritional adjustments and even medication. These efforts have helped astronauts maintain their muscle mass during missions, enabling longer stays in space. And back on Earth, the research has informed therapies for those suffering from muscular disorders or prolonged immobility. Our understanding of muscle atrophy led to the next significant breakthrough. In the 1980s, space medicine turned its attention to one of the biggest threats in space: radiation. This invisible menace poses a significant risk to astronauts' health. leading to an array of medical complications from cataracts to cancer. The primary source of this radiation is our very own sun, spewing out a stream of charged particles known as solar wind. Yet the universe beyond our solar system also contributes with cosmic rays from distant supernova. These high-energy particles can wreak havoc on the human body at a cellular level, interfering with DNA and increasing the risk of mutations. To combat this, space agencies around the world started to develop radiation protection measures. One of the first steps was to enhance the shielding of spacecraft and spacesuits. Traditional materials like lead were too heavy for practical space travel, so scientists turned to new, lightweight materials. Some of these include water-based shields, because water is excellent at absorbing radiation, and plastic shields, which are lighter than metals and better at blocking out some types of radiation. Additionally, scientists started to explore radiation-protective drugs that could potentially boost the body's natural defenses. These future-focused efforts are critical in our quest to explore deeper into space, where radiation levels only increase. With these advancements, we've been able to take another step forward in space exploration. But it wasn't just about physical health. As we ventured further into space, the psychological effects of long-duration space missions became evident. The 1990s marked a new era in space medicine, focusing on the psychological well-being of astronauts. This period saw the recognition of the fact that space isn't just physically demanding, but also mentally challenging. Psychological support became a pivotal aspect of space missions, especially those of long duration. Imagine being confined to a small space with limited human interaction for months on end. The isolation and monotony can take a toll on even the most resilient minds. This is where the fourth breakthrough in space medicine comes into play. Researchers started focusing on strategies to ensure the mental health of astronauts. They developed programs to help astronauts cope with the unique psychological stressors of space travel. These programs included pre-flight training to prepare them for the emotional strains of space missions and continuous support during the mission. Astronauts were given tools to manage stress, anxiety, and interpersonal conflicts. They were also provided with recreational activities to break the monotony. Video calls with loved ones back on Earth became a routine part of life in space, providing a much-needed emotional connection. The importance of psychological support in space medicine cannot be overstated. After all, the success of a mission doesn't just rely on the physical health of the crew, but also their mental well-being. The advent of the 21st century brought with it more complex challenges and solutions. Indeed, as we push the boundaries of human space travel, the psychological support systems for astronauts will only become more crucial. As we moved into the new millennium, space medicine embraced the power of technology. The fifth and sixth breakthroughs, telemedicine and biotechnology, emerged as pivotal tools in the quest to explore the cosmos. Telemedicine, the remote diagnosis and treatment of patients through telecommunications, became a lifeline for astronauts. Imagine being on Mars, millions of miles away from the nearest doctor. A medical emergency would be catastrophic without the ability to consult with Earth-based medical experts in real time. Telemedicine made this a reality. It bridged the gap between space and Earth, ensuring that astronauts could receive medical advice and even perform complex procedures with guidance from specialists thousands of miles away. But telemedicine didn't only benefit astronauts, it also transformed healthcare on Earth. Remote communities, for instance, could now access specialist care without needing to travel long distances. The technology developed for space medicine had a profound impact on Earth, democratizing access to healthcare. As telemedicine was revolutionizing healthcare, biotechnology was providing new insights into how the human body adapts to space. Biotechnology, the seventh breakthrough, allowed us to study cellular and molecular changes in astronauts. This research led to a greater understanding of how space travel affects the body, from the impact on our immune system to changes in our DNA. The eighth breakthrough came when biotechnology was used to develop new treatments and countermeasures. For example, research on the International Space Station led to the development of a synthetic version of a naturally occurring protein. This protein, used to combat muscle atrophy in astronauts, has since been used to treat conditions like muscle-wasting diseases on Earth. The advancements in telemedicine and biotechnology have proven crucial in our journey to understand and mitigate the health risks of space travel. They have enabled us to provide medical care to astronauts in the most remote locations and to understand the very fabric of our being in ways we never thought possible. But perhaps more importantly, these advancements have also benefited life here on Earth. The technology and knowledge gained from space medicine have been used to improve healthcare, treat diseases, and expand our understanding of the human body. These technological advancements revolutionized space medicine, but the journey didn't stop there. The latest advancements in space medicine are truly groundbreaking. Have you ever wondered about the future of space travel? Well, the 9th and 10th breakthroughs in space medicine have something to say about that. They're all about personalized medicine and artificial gravity. Personalized medicine is a concept that's been growing in popularity on Earth, and it's just as important in space. It's the idea that healthcare should be tailored to the individual based on their unique genetic makeup. The same drug might work differently in different people, and personalized medicine aims to take that into account. In the context of space medicine, personalized healthcare could mean the difference between a successful mission and a disaster. Imagine if we could prevent astronauts from developing space sickness simply by adjusting their medication based on their genetic profile. Or if we could predict and manage the risk of radiation-induced cancer by analyzing the individual's genetic susceptibility to radiation. The possibilities are endless and incredibly exciting. But personalized medicine is only one part of the puzzle. Artificial gravity is another game changer. For years, scientists have been grappling with the effects of microgravity on the human body. We know that it can cause muscle atrophy, bone loss, and a host of other health issues. But what if we could create artificial gravity in space? This isn't just the stuff of science fiction. Researchers are actively working on ways to simulate gravity in space. One idea is to use centrifugal force. By spinning a spacecraft, we could create a force that mimics gravity. Another idea is to use magnets to generate a gravitational field. These aren't simple tasks, of course. There are a lot of technical challenges to overcome, but the potential benefits are enormous. With artificial gravity, astronauts could live and work in space for extended periods without suffering the debilitating effects of microgravity. In essence, personalized medicine and artificial gravity could revolutionize space travel. They could make long-duration space missions safer and more feasible. They could open up new possibilities for exploration and colonization, and they could bring us one step closer to becoming a multi-planetary species. These breakthroughs mark a new era in our pursuit of the stars. As we look to the future, the possibilities for space medicine are limitless. We're on the cusp of a new era where our understanding of human biology meets the wonders of the cosmos. Imagine a future where we could harness the body's own regenerative capabilities in zero gravity to heal injuries and illnesses. Or perhaps we could develop advanced shielding techniques that protect astronauts from dangerous cosmic radiation. The challenges of deep space exploration might even push us to revolutionize our approach to mental health, paving the way for therapies that help astronauts cope with the profound isolation of space. Furthermore, the advent of artificial intelligence and machine learning could usher in a new age of telemedicine, allowing for real-time monitoring and diagnosis of medical conditions in space. The journey of space medicine is a testament to human ingenuity and our relentless quest for knowledge. As we reach for the stars, we're not just exploring space, but also the vast potential within us. So, what have we learned from this journey through the history of space medicine? From combating motion sickness to pioneering muscle atrophy research, from developing radiation shields to providing psychological support, each major breakthrough has been a leap forward. The advancements in telemedicine, biotechnology, personalized medicine, and artificial gravity are not only transforming space travel, but are also reshaping healthcare on Earth. As we continue to reach for the stars, the field of space medicine will undoubtedly continue to evolve, bringing new breakthroughs that will not only benefit astronauts, but also improve life here on Earth. As we wrap up our journey through the fascinating world of space medicine, we want to hear from you. Did you learn something new from this video? If so, please give it a like and share your newfound knowledge with us in the comments section. Our community thrives on the exchange of ideas and perspectives. Don't forget to subscribe and press the bell icon to stay updated on our latest content. We have so much more to explore together, and we can't do it without your support. So share this video with your friends and family, and let's continue this journey of discovery together. Remember, Every small step in space medicine is a giant leap for mankind. Until next time, keep reaching for the stars.